So today we are carrying on with the story of APs and GPs. In particular, we are now going to work through some past paper questions. So using the techniques and the theories that we worked on last week, I'm actually applying them in questions. So we've got a couple for warm-ups and then we're going to do one of those wonderful comparisons. Okay, so warming up. First term in a progression is 36 and the second term is 32. Given that the progression is geometric, find the sum to infinity. So we've got a GP. First term is 36. So A equals 36. Second term is 32. So U2 equals 32. However, we don't stop there. Remember, we always take it all the way down. U2 is AR. But A is 36, so this is 36R. To find the sum to infinity, remember sum to infinity is A over 1 minus R. So we've got A, and we look at our magic summary and we can see there's an equation popping out here where R is an unknown. So we can solve for R. So we know that 32 equals 36R. So R equals 32 over 36. I'm not trusting my brain today. I am going calculator based. R equals 8 over 9. Okay, so then we can calculate the sum to infinity. Sum to infinity equals A, 36, divided by R, 1, minus 8. Okay, let's rewrite this, because my handwriting does not fit here. So sum to infinity equals A, 36, over 1 minus 8 over 9. So plug that in a calculator. 36 over 1 minus 8 over 9, 324. So nice little gentle warm-up. We needed A, we needed R. We were given A, we could calculate R. Plug them in, sum to infinity sorted. Okay, so next question. I gave myself plenty of space to work on today. Given instead that the progression is arithmetic, so an AP now, find the number of terms in the progression if the sum of all the terms is 0. Okay, right. So let's just get the information from the first one. A is 36 and U2 is 32. So we've got a question come in that we've got people here who weren't here last week and they haven't quite got to this stage in the course yet. So it is up to you. What I will do then is I will slow my game down a bit, do a little bit more explanation, and you are welcome to stay around, or you can skip, or you can listen and have fun and know that this is coming your way. Don't worry, there are many more lessons explaining these in detail. Okay, so it's up to you whether you want to watch it now or at a later stage. Okay, so basics. APs are all about addition, GPs are all about multiplication. Okay, and what they do is they have lovely repetitive patterns. It's not like IG where you get all sorts of things chucked at your head. Okay, so we have a set of formulas to deal with an AP. We have a set of formulas to deal with a GP. Formulas aren't all that complex. So the skill comes in pulling the information out of the question. And that's where we talk about this summarizing and why it's so important. Okay, so we have an arithmetic progression, so all about addition. We know that A equals 36. We know that U2, the second term, equals 32. And we also know that this equals A plus n minus 1D. So A is 36 plus n minus 1 is 2 minus 1 is 1. And 1 times D, we don't know D. Okay, but there we go. 32 equals 36 plus D. We can calculate D. Do we need to find the number of terms? N equals, we don't know. In the progression, if the sum of all the terms is 0. So we also know that Sn equals 0. Okay, but then it's that expansion again. We don't leave it at Sn. Sn is 1/2 n 2a plus n minus 1 times d. And now we see, aha, well, we can solve this for n or d, but we've already can use this first equation here to get d. We can plug it in, we can solve for n. So in this case, we're going to do a sequencing of equations. So our first one, for value of d, 32 equals 36 plus d. So d equals 32 minus 36, which is minus 4. Okay, now we know that d is going to be minus 4. So we need, for value of n, our next equation is 0 equals 1/2 n. 2 times 36 is 72. Plus n minus 1, and remember that count? Remember I said always substitute in brackets, because here we have it, that minus 4, close brackets. Now we can simplify and solve, multiply by 2 to clear that, so 0 equals n, 72 minus 4n plus 4. Simplifying inside our brackets, 0 equals n. This would give us 76 minus 4n. Okay. Now, we do not want to divide by n. Okay. So we need to solve this. What we have here is effectively a quadratic. We have an n equals 0, or we have a 76 minus 4n equals 0. So 4n equals 76, and n equals, let's double check it, 19. Now we've got to use our brains a little bit, because the correct answers to this quadratic here is these two. But this one here is not applicable. We're not going to have a number of terms in the progression be 0. So, therefore, number of terms equals 19. Are we happy and with warm brains? Yes, this is the one I want. Okay, so in an AP, the sum Sn of the first n terms is given by this nonsense. 2n squared plus 8n. Find the first term and the common difference. Right. Well, we know that Sn also equals 1/2 n 2a plus n minus 1d. That's not going to help us much though, if we think about it, because here we have an n, we have an a, and we have a d. We've got 3 unknowns. We only have one equation. So there must be another way of doing this. Right. Find the first term. Okay, so the first thing we should be finding should be the first term. We know that Sn is related to n. So what if we did the sum of 1? The sum of 1 is the first term. 2 times 1 squared plus 8 times 1 is 2 plus 8 is 10. So our first term, S1, the sum of one term equals A, equals 10. Okay, so now we know the first term. We also know, if we think about what a sum is, the sum of 2 terms is going to be the first term plus the second term. But we can also, because this formula relates it to n, so let's just take this one out because we're not using this time. It's a different kind of question. S2 equals 2 times 2 squared plus 8 times 2. So 2 times 4 is 8 plus 16. This gives us, don't trust my brain, 24. Right, now, remember this is S1 plus S2. So we know that A plus U2 equals 24. Sorry, it's not S1 plus S2. S2 is A plus U2. So another reminder not to get confused between your sums and your terms. A is 10 plus U2 equals 24. So U2 equals 14. Right? But we know that U2 is A plus D. So we know also that A plus D equals 14. So D equals 4. So they asked us to find first term and common difference. So this is an idea of making you, again, make that summary, pull out your information and look at what you got. In this case, the world was slightly different. Okay, we have a summary that when we take it all the way down, it doesn't work. But that then prompts us to think about something different. And we can see that everything relies on n, and we know n. Okay, then we understand really what a sum is about. The next part of this question is one of those classical comparisons. Okay, so the next level of why your summary is so important. I think I should call this lesson APs and GPs, why your summary is so important. Okay, so here we have lots and lots going on. First two terms of a GP are 64 and 48. First three terms of the GP are also first, ninth, and nth of an AP. Find the value of n. Breathe. Okay, so we have a GP, we have an AP. First two terms are, so A equals 64, U2 equals 48, equals AR, and U3, we're not told anything about it. But we do know that it equals 64R squared, because AR to the n minus 1. For the AP, these are the first, ninth, and nth. So the first, the ninth, and the nth. So the first term is also 64. U9 is A plus 8D, A plus n minus 1D. So 64 plus 8D. Okay, but we don't know what the value is. And UN, of course, is 64 plus n minus 1D. Now we got to think nicely, okay? We got to think about what's going on here, because the reason we set this out like this is because the magic appears here. These are equal and these are equal. So if we look on this line, 48 is equal to 64R, which is equal to 64 plus 8D. Aha! We can use this equation here to do the value of R. And we can use this big equation to do the value of D. Now, if we have the value of D, then this is happy. Okay? So we would be able to calculate for N if we had something on the other side. Well, if we've got the value of R, we can get something on the other side. So let's work through this systematically. First off, let us do the value of R. We know that 48 equals 64R. So R equals 48 over 64, which is 3 over 4. So for value of D, let's get all the equations sorted on this line first. We know that 48 equals 64 plus 8D. So minus 16 equals 8D, D equals minus 2. We're getting sorted, we're getting settled. Now we need a value. So we need this value of the GPU3 in order to equate it to our expression for the APUN. So for value of GP third term, U3, we know that U3 equals 64 times 3/4 squared. And remember, put that fraction in brackets, otherwise the exponent doesn't apply to the top and the bottom. Brackets, brackets, brackets. So U3 equals 64 times 3 squared is 9 over 4 squared is 16. Gives us 36. And you see the beautiful numbers we're working with. It's nice and simple. Now we have everything we need, because now we have a value here to equate on our big pink equation to this one, and we need to calculate n, and we have d. So for value of n, we know that the U3 is 36, and we know it equals 64 plus n minus 1, substituting in brackets, minus 2. So 36, 64, what have we got? 36 equals 64 minus 2n plus 2. So 2n equals 64 plus 2 minus 36 equals 30, and n equals 15. So another reiteration that our calculations are not what's complicated. Okay, what's complicated is getting where do our equations come from. But the complication of that reduces so much dramatically as soon as you do your summary. So you always summarize all the way down to the bare details. A, R, N, D, those must be there. If you have things that are equal, you put them on the same line, because then it's easier for your eye to see across and to see those equations that pop out. And then it's just a case of systematically working through all these equations that you've created in order to calculate the values you need to calculate where you're going. Are we happy with this comparative type of summary, ladies and gentlemen? Okay, so we've got happy people and we've got people happy with me doing it. So I do promise that I was not so good when I first started. It takes a lot of practice to get these. But when you do that practice, they do get easier because it's the same things that are popping out, with the exception of the odd one or two to make you really think. Okay, so practice makes perfect. They do make sense. Let us have another example. Okay. So a GP, we write it down, GP, has third term of 20, U3 equals 20, and a sum to infinity, which is 3 times the first term. Sum to infinity equals 3 times the first term, 3a. Find the first term. Well, U3, remember, also is AR squared, AR to the n minus 1. Okay, and the sum to infinity is a over 1 minus r. So again, you see the value and the power of the summary. Here we have 2 lines, which means we have 2 equations. And in each equation, we have 2 variables. So 20 equals AR squared, and 3a equals a over 1 minus r. So we can solve these simultaneously for r and a is the one that we are looking for. So what is going to be the simplest way to do this? This is not such a nice one. We're going to take a bit of time to think. Okay, because we could do a equals 20 over r squared. We could do r equals root 20 over a. If we divide by 3, we still got a on both sides. So we want to get everybody together. So I think on this one I'm going to go with r equals root 20 over a. For the simple fact that then I'm only going to be substituting it once. Okay, so also I'm getting then rid of my r and just solving for a first term. I don't have to do that second half of the simultaneous equations. So 3a equals a over 1 minus root 20 over a. Let's bring that up to start with. 3a 1 minus root 20 over a equals a. So this would give us 3a minus 3a root 20 over a equals a. Wowzers. Okay, we're going to need to square both sides to get rid of this square. So remember, when you're going to square sides, not terms. So this is then going to give us 3 times 3 is 9a, oh, not q, 9a squared minus 3a. Okay, so I know that my brain is not to be trusted today, so you get a nice little aside on how to do these when they're a little bit ugly. So rather than trying to do it in my head like I normally do, I show both brackets. Then I can see that I've got, there's my 9a squared. I'm then going to have two terms that are the same, okay? And they're going to be 3 minus 3a times 3a with a p as well. P is standing in for our little ugliness here. This is not going to help us. Am I making a complete hash of this? Okay. Rewind. Okay, we have another alternative suggestion that has come in. Divide by 3a to find r, then substitute r in that nonsense. Okay, let's try that route. So, see, this is 3a, 1 minus r equals a. See, if we divide by the 3a, our a's are going to cancel. So we get a equals 45. And we are actually going to take a very quick break and check the answer for this one. Summer 11, 13, 6. You know those days when you just don't trust yourself. What are we doing? Summer 11, 13, 6, part A. Summer 11, 13, 6. Okay, so we are right. But it's again a lesson to yourself. Okay, so the thing that I didn't like about this one and why it was like bugging me is because when we divide by that 3a, of course we get a over 3a and our a's cancel and we're left with the 1/3. And generally I do my best to avoid dividing by a variable. So in this case, we solved for r and it worked, but don't go being blasé about dividing through by a variable. Okay, so are we feeling a bit shaky? Shall we do another one? And let's see the world come back to rights. Okay, so an AP is such that the 8th term is equals 3 times the 3rd terms, U3. Show that the sum of the first 8 terms is 4 times the sum of the first 4 terms. Right, so U8 is A plus 7D, and this equals 3 times a plus 2d. So a plus 7d equals 3a plus 6d. And now we need to show S8 equals 4S4. So let's get this tidied a little bit more. Let's get our 2a equals 7d minus 6d is d. Because now you can see we can simplify the world. Okay, it does work, I promise. Half S8, so half times 8, 2a plus n minus 1, 7d, equals 4 times a half times 4, 2a plus S4, so 3d. So let's just simplify the world a bit. 4 times 2a plus 7d equals 4 times a half times 4. Well, that gives us 2 times 4, which is 8, 2a plus 3d. But we know also that d equals 2a. So 4, 2a plus 7, 2a, equals 8, 2a plus 3, 2a. We simplify. 2 plus 7 times 2 is 16. So here we have 4 times 16a. And here we have 8 times 2 plus 3 times 2, which is 14a. Are your fingers tightly crossed? This is 64a. And this is not. Ladies and gentlemen, it has turned out to be one of those days. So, golden star to the person who can spot the problem. What have I done wrong? Should it 14a be? Yes. Okay. A reminder that your teachers are human. 2 times 3 is 6. 6 plus 2 is 8a. And 8 a's are 64a. Then we can have a shown, because we have shown it. And in this case, we can have a smiley face. Because as a team effort, we have managed to solve this. And I have also demonstrated that my students are awake during these lessons.